Well, our last speaker, and certainly not the least, is a person that I've been working with since Well, our last speaker, and certainly not the least, is a person that I've been working with since I came to Congress 8 months ago. As you might know, Congressman Ryan and Congressman Takano are co-chairs of the Mako Caucus, and Teresa is the staff that works for Congressman Takano, and we have been meeting on a regular basis, sometimes once a week or more, and sometimes we would like to meet more, but it's not possible. And I have learned a lot from her about the Mako Caucus and also all the activities that she has been organizing on behalf of the Mako Caucus. And Teresa is actually on the front teaching engineering. That is before she came here, and she'll be doing the same thing after she leaves here. She goes back and she is every day teaching the students this wonderful aspect of engineering.
As Said said, I'm a high school engineering teacher by trade. I am placed in Congressman Takano's office this year to work with the Congressional Maker Caucus. So if you're on my email list, you probably get lots of stuff from me. But I'm here today to tell you a little bit about my experience and how I ended up here. Quite a few years ago, you mentioned Space Grant Consortium, but our Space Grant Consortium did a meeting, and I found out about an engineering program that was offered for one semester. And so I got on board with that, went through the curriculum process, and started teaching that in 2004. But 3 years ago, because I primarily still taught physics and chemistry, 3 years ago, I got a chance to, that's 4 years ago now, got a chance to help write a grant. Mississippi decided to, oh, by the way, I'm from Mississippi, but they decided to put money into placing engineering in the career and technical programs throughout the state of Mississippi. And to support that, because the materials to teach engineering are quite expensive, schools and school districts were allowed to write $150,000 grants that were supported by our legislature to put that into place in those districts. And I helped write one grant, and then now that is the class that I teach. So the justification for teaching engineering at the high school level, it's multifaceted. I do think there are a lot of things that happen in the engineering classroom that it's really hard to justify those or to measure those by the standard tests that we give. But I do see what happens every day, and I do think this is a great program. But the state of Mississippi, the justification was for students to learn to solve problems with the engineering design process, which we feel like is a really good problem-solving process. We know that it's important. In Mississippi, we've always had Ingalls shipbuilding, so we had a big engineering push there. We have now have in the state 2 automotive manufacturers, Toyota and Nissan. So we need students who are prepared to solve those types of problems, and we feel like they can do that with the engineering design process. The other thing is we wanted to provide, whoops, I get clicky here, provide students with hands-on experiences related to the application of engineering concepts, and you'll see that in a minute. Sometimes that is a type of machinery or tool or technique that we teach students. The other thing we're interested in, and I have been for a long time, are the 21st century skills that students learn. We sometimes call them soft skills, job skills, employability skills. They have lots of names. But these are those lifelong skills that students need to learn, more than just subject areas that I feel are important. And talking to industries in the state of Mississippi, we found out these are things that the employers want from the people. Even if they're coming in out of high school with a certification, they still want these skills from students. So that was the justification for putting in the program. Okay, it is, and what I'm going to tell you, and this is as Chris said, every place looks different, and I think that's a good thing. I don't think that our engineering program should look like Michigan, should look like another state's program, because what we need in our state is different than what other people need. So it does look different. The original engineering program I taught was in the high school and received a half of a math credit and a half of a science credit. What I teach now is a 2-year career and technical education program. We are at a separate center. We service 4 high schools in our county, which is always interesting working with schedules. And career and technical education is a little different than teaching it in the regular high school curriculum. It allows me a lot more flexibility in student projects, but it also is harder to get students to the center because they have to be bused to the center. So as with everything else, they're always good and bad. One of the first things I teach students is computer-aided design. So much of what we do in engineering is design oriented, and I love sketches and I love documentation, but to be able to produce a lot of things, you need to understand computer-aided design. We went to the universities. We have 3 universities that have engineering programs. I went to the universities and found out what program they were using, and that really is what drove the program we chose, which is SolidWorks CAD. There are many other CAD programs, notably Autodesk programs, which I currently work with, but in each state, a lot of what's driven in career and technical education is what do your universities want, what do your industries want, and we go out there and find that, and that's why we do SolidWorks. One of the things we also do is 3D printing. I show this particular picture because after they do SolidWorks and learn the basics, and by the way, we teach SolidWorks at a level that they can get a certification to do SolidWorks for engineering firms, do CAD drawing for engineering firms. Not all of my students do that. Not all of them are interested, but I have had a few students take the exam, which is fairly inexpensive. It's $99, but it is a way of employability, because one of the things in career and technical education we're always interested in is employability. We need our students to be employable. 3D printing is a fun way of actually printing out what you created in your SolidWorks drawings. Some of my students push the limits, some of them don't. They all have the opportunity. This was, as you can imagine, this was a girl who created this cupcake and then painted it after we 3D printed it. I like students to have options and ownership of their work, and this way with 3D printing we can do that fairly inexpensively. Another thing we do a lot in the first year is robotics. It's a real interesting mix. We do have in the state of Mississippi a 9th grade STEM program for which they do Lego robotics. But in each of our 4 schools, the programming skills they come to me with is very, very different. The building skills they come to me with is very, very different. So this is a very self-paced. We do VEX robotics. Again, that was a choice made by the state of Mississippi, so that I can work with other engineering teachers. If I have a problem with a program, I have about 10 teachers that I call, or they call me about certain things, so that we can all work together. So there's some things in programs that should be the same across the state, and then there are other things that we do differently because of our local industries. I have a solar plant and an injection molding plant in my district, so we do more things with that than others that are closer to the automotive plants, so it's a little different. But the robotics is a fun way to get kids interested in learning physics. My students, if they stay both years in the program, get a physics credit. We worked out that with the state of Mississippi, went through the curriculum process. to make sure that they're getting everything that the physics curriculum also requires. Not all career and technical programs do that. It's just something we were really interested in because, as you can imagine, high school schedules are very packed, and we want our students to be able to get the most bang for their buck. This robotics slide is actually a second year robotics. I teach them the basics. We do a lot at the beginning that is very similar, so that the ones who are very good at building and have that experience, they can move quickly through it. Others who are just learning, they have a little more time. This is second year. I have a colleague who does the second year program. In the second year, you'll see they're a little more complicated. Some of them are still mobile. Others, like on the bottom left, it's kind of hard to see there, but there's a conveyor belt system that works with a robot arm. It's a more complicated project. Then also, because of the industry connection, we teach them how to manually drive and automatically program a robot arm, because in industry, a lot of the robotics are robotic arms and things like that that are hand programmed. We do participate in robotics competitions. We particularly do VEX robotics, and it's a good chance, especially for the kids who are more advanced and really, really like the robots and want to work on it. We even have kids who go buy the VEX kits are about $500. You can buy them online. We've had kids go buy them themselves because they love them so much. So I can't say enough about robotics. It's a great thing. One of the other first year projects are our civil engineering projects. In the state of Mississippi, almost every student who majors in engineering will work in some way, shape, form, or fashion, regardless of their major, with some type of civil engineering, because it is the biggest type of engineering in Mississippi. Roads, bridges, buildings, all of those things, even a lot of the big plants. A lot of it's tied to civil engineering. That's just particular to our state. So we work with our local Department of Transportation and do civil engineering projects. This one is a boom lever, and then we do bridge projects also. Computer and numerical control machining is a fabulous, fabulous, hardest thing I've ever learned how to do kind of thing. This is where you take your SolidWorks and you do a subtractive manufacturing. It's a year 2 project. Some students go crazy and do crazy things like you see here, or even more 3D structures. It is amazing to me when high school students can learn to do this, and when they go to the universities, like I have one at Mississippi State University right now, and they tell people they've done this in high school, and people are shocked, because we still have not reached the point in Mississippi where every school district offers engineering, which is what we would really like to do. But the skills that they learn from this is fabulous. Also in the second year, they learn hydraulics, pneumatics, and thermodynamics, and you'll see some of our projects here. They're learning the science and using the science to solve an engineering problem. And that's really, to me, what engineering is about. It's applying the science concepts to a real-world problem. Now, some of our projects are more prescriptive, others are more open-ended, and it just depends on the level of the students and where they are in our curriculum. One of the other things about CTE is we're very much tied to industry in our state, and we do industry tours. On the right, you'll see our local Department of Transportation. They come to my school, they bring all the materials, the kids come up with a concrete formulation based on what the Department of Transportation engineers teach them. They bring the materials, we build the concrete cylinders, which is exactly what they use to test concrete projects with. Then you'll see on the right the lime baths. Those cylinders have to be cured in a lime bath for 2 and 4 weeks, and we go to their office and they actually show us how they test these, and so the kids get to kind of compete and test their concrete cylinders. One of the really important things to me in going to the Department of Transportation, I am not one of those people that thinks that every one of my students is going to be an engineer, because it's absolutely not going to happen. The skills they learn can be applied to anything that they do in their life, regardless. Going to the Department of Transportation also shows a 2-year employability field, which is an engineering technician. The Department of Transportation hires quite a few technicians, and they make very good livings in doing these jobs. So I want my students to understand you don't have to go get a 4-year degree in engineering if that's not where you're headed, if you don't want to stay in school. Some students have weaker math skills, and in engineering you have to have really strong math skills. So this is another way of students finding fields, and I actually have several students who've gone through the 2-year engineering programs in our local community colleges. It's just another path, because again, to me, it's about skills and it's about being employable. During the second year, and when I can in the first year, it really becomes a matter of applying what you've learned. Now you have these tools. Now you have these skills. Can you apply them to a real-world problem? And we at our technical center have an automotive technology program. We again have automotive plants in our state. So what my students do sometimes is design things for them. We try to work collaboratively with them, which is like one of my favorite things to do. So you'll see a carburetor cover, you'll see a gauge holder the students designed and then we printed. Of course, the one that you see on the right we had to redesign, which is a very important skill. Engineering iteration to me is a very important skill for students to learn. To redesign, you're always going to be improving things. You're never going to get to that end point. The one on the left is actually a clip that goes on a Nissan Pathfinder that was re-engineered from a broken clip where the automotive group was going to have to buy a $200 whole setup, and I actually did most of that work. But it shows that idea of re-engineering or reverse engineering something that we can use and 3D print, because I love 3D printing. At the end of year 2, students get to do what's called a passion project. Some of them, we have to guide them a lot. Others just take it and run with it. And you'll see some passion projects here. Cell phone holders. The one on the left is a blue light that's made of a glass jar, a 3D printed base, a CNC plaque, and electronics. And what you didn't see in the pictures is we do quite a bit of electronics because Internet of Things is very big right now. Automatic cat feeders, kids are interested in these types of things. But some students do a lot of it, others are not as interested in that, and they have the option in our second year to take and run with some of these things. So each kid gets a different experience. So the impact, students are prepared to enter and succeed in engineering programs offered at 2- and 4-year colleges, depending on what their interest is. Talking to professors at the universities and at the community colleges, what they really, really want us to do is have students who can understand and work through the engineering design process. At the universities and the community colleges, they feel like they can teach them the knowledge that they need. We want to give them a leg up, and this is, again, based on conversations with the colleges and what they want. We do have issues in Mississippi that we are working on. One of them is underrepresented minorities and women in engineering. I still have only about 10% of the students that I teach who are women or minorities. It's very small. In a CTE program like I teach, I get a small percentage of the students. Our district is rather large. Because of the size of our program, I can only teach 45 students a year, and that is not even a big enough portion of our students, and our program is competitive, so we have students that we have to turn away every year. What I would like to see is is a program like this expanded so that it would be offered to more students. Another thing I see in students is persistence or grit, and that's one of the skills that I spend a lot of time working through. Quit is not a word that you use in my classroom, or I can't is not a word you use in my classroom. So again, we have issues that we're still working through. And I cannot leave here without making a plug for the Congressional Maker Caucus, for which my fellowship has been working with. If you don't know what the Congressional Maker Caucus is, it's a group of members who are interested in all things maker movement, maker spaces, how this looks in libraries, museums, and the expansion of it throughout the last over 10 years that it really has been called the maker movement. And we spend a lot of time trying to connect members to their local maker spaces and libraries that have 3D printers and do making. And we will be hosting the Capitol Hill Maker Fair June 21st, for which Saeed is working with me on. So we would welcome you to sign up for that.